Hi YouTube friends, I am teacher Regy Safadão and today we're talking about the thermal volume expansion. Are you ready? So join us!
Hi YouTube friends, I am your teacher Regy Safadão and today we are going to have our class number 4 of SET. Pay attention to our opening. As we already know, this is our channel of Mathematics Without Frontiers, and here we have classes of physics, mathematics, and English in two versions, one in English and the other one in Portuguese. Go there and visit us. Our classes in Portuguese are really wonderful. So let's see, today we are going to talk about thermology. Thermal volume expansion is our subject of today. Well, we are going to solve some questions about it, all right? Explaining you all the details in order to make you understand this subject better, all right? So let's see our question number 1. Knowing that the volume expansion coefficient of the plastic in which a cube was made is 24 times 10 to minus 6 per degree Celsius, and that its volume is 13.2 cubic inches at 5 degrees Celsius. Calculate its new volume when heated up to 50 degrees Celsius. Okay, so we have here an illustrative picture, and what was given: initial volume, initial temperature, final temperature, and gamma of plastic. Okay, these were given, and what is required? Let's remember, required the final volume. Okay, so we can do it in 2 minutes in 2 steps. Okay, well, at first I like to calculate the change in temperature. All right, so the change in temperature is the final temperature minus the initial temperature, always done like this. So, and then we are going to calculate the final volume, all right, by this formula. Let's see. So the change in temperature is 50 minus 5. It gives 45 Celsius degrees, okay? Now we can plug the values into the formula, okay? Let's see. So the final volume is 13.2 times 1 plus 24 times 10 to minus 6 times 45. That is the change in temperature. Now, let me pick up. I always forget this. Let's get a laser pointer. Okay, so let's see. You can realize that 24 and 45 are in different colors. They are in pink. Okay, why? Because I'm going to multiply them only right now. Okay, so 24 times 45. Let's do it. So it is 1080. Okay, now I'm going to multiply 1080 by 10 to minus 6. What I have to do, I'm going to move the decimal point 6 units to the left. Okay, so the decimal point is right here. I'm going to move it 6 units to the left. Okay, so let's count with me. 1, 2, 3. Okay, 4 units. Okay, so it's lacking 2 other units to be counted. Let's see down here. I am here. Right here, 4, 5, 6. So the decimal point is going to be written right here. And so the result is 0.00108. Now we are going to add these two values. Number 1 is going to be added with this decimal value, all right? So how am I'm going to do this? This number 1 is going to be written right here, okay? So let's see. Now I have that. 1 plus 0.00108 is 1.00108. Now let's just multiply and finish our question. So the final volume is about 13.214 cubic inches. Okay, let's compare. I just like to compare when I finish one word problem. See the final volume and see the initial volume. Okay, the initial volume is 13.2 and the final volume is 13.214. Okay, this number is just a little bit larger than 13.2, isn't it? Can you see? Can you compare? Okay, so what it means? It means that there was, yes, there was a final, a change in volume. There was a change in volume. All right. So let's go to question number 2. Come on, let's see. Question number 2 is, here it is. Platinum is a noble metal that is very difficult to oxidize. It is used in medicine, in dental and orthopedic implants. Consider a platinum block initially with 10 cubic centimeters of volume and at 25 degrees centigrade. That was heated up to 125 Celsius degrees. Determine the volumetric expansion that occurs, being 9 times 10 to minus 6 per degree Celsius, the linear expansion coefficient of platinum. Let's see. As always, here we have only a illustrative picture. And what was given? Initial volume, initial temperature, final temperature, and the alpha of platinum. Pay attention. This is something the problem gives in order to make you make a mistake. Okay, they did not give you gamma, they gave you alpha. Okay, so we have to pay attention. We have to convert. Okay, just 1 minute. Let's see what is required, the change in volume. Great. So we know that gamma is 3 times alpha, okay? So if alpha is 9 times 10 to minus 6, gamma is 3 times 9 is 27. So gamma is 27 times 10 to minus 6 per degree Celsius. Okay, let's see, let's do this question, this problem in 2 steps. In 2 minutes, we can do it. So the change in temperature is 125 minus 25, so it is 100 Celsius degrees, okay? Now let's plug the values into the formula, okay? Let's see. So delta V is gamma, 27 times 10 to minus 6, VI, I mean, is 10, and the change in temperature is 100. So pay attention that the colors are different. 27, 10, and 100 are in blue. Why? Because I'm going to multiply them only right now. Okay, so 27 times 10 and times 100. It is 27,000. Now we are going to multiply 27,000 by 10 to minus 6. What it means? It means that we are going to move the decimal point 6 units to the left. Okay, so the decimal point is right here. So let's move it 6 units to the left. Let's count. 1, 2, 3, 4, 5. Only one more. Okay, so I was here in 5. Now 6. So the decimal point is going to be written right here. So the change in volume was about 0.027 cubic centimeters. Okay, thank you very much for watching this. Let's see question number 3. Come on, here it is. How much is the change in volume of a brass sphere when the temperature increases from 10 degrees Celsius to 140 degrees Celsius? It is known that before being heated, the volume was 125 cubic centimeters and that the brass linear expansion coefficient is 18 times 10 to minus 6 per degree Celsius. Okay, so another illustrative picture. What was given? VI, TI, TF, and alpha of brass. Pay attention again. They didn't give you gamma, they gave you alpha. So another conversion is going to be done. Let's see. What is required? Alpha V. Sorry, delta V. So gamma is 3 times alpha. Gamma is, well, if alpha is 18 times 10 to minus 6, so gamma is 3 times alpha. 3 times 18 is 54. Okay, so gamma is 54 times 10 to minus 6 per degree Celsius. Okay, let's do in 2 minutes. Let's calculate first delta T and then delta V. All right, delta T is 140 minus 10. It is 130 Celsius degrees. And delta V, the change in volume, is gamma times VI times delta T. So delta V is 54 times 10 to minus 6 times 125 times 130. Pay attention that the colors are different, okay? I always do this in order to make you see, in order to make you realize what's happening. So 54 times 125 and times 130. So it is, okay, 877,500 times 10 to minus 6. How am I going to multiply this? Well, I'm going to move the decimal point, okay, 6 units to the left. Okay, well, the decimal point is here. Let's count. 1, 2, 3, 4, 5, 6. Okay, very good. Let's see. So delta V is about 0.878 cubic centimeters. Okay, very good. So far, so good. Let's see now. Question number 4, the last one. A Pyrex glass jar has an initial volume of 800 milliliters at 30 degrees Celsius. Find its volume at 130 degrees Celsius. They give us alpha of Pyrex, 3.2 times 10 to minus 6 per degree Celsius. Pay attention once again. That alpha is not going to be used. We are going to use it only to convert from alpha to gamma. Remember, gamma is 3 times alpha. So another illustrative picture, and what was given? VI, TI, TF, and alpha of Pyrex. And what is required? The final volume, okay? So let's do the conversion. Gamma is 3 times alpha. So alpha is 3.2. So gamma is 9.6 minus times 10 to minus 6 per degree Celsius, okay? Now, in 2 steps, in a couple of minutes, let's find the delta T. Delta T is 130 minus 30. So it is 100 Celsius degrees. And the final volume is 800 times 1 plus 9.6 times 10 to minus 6 times 100. Pay attention once again. Let's multiply only 9.6 by 100. So it is 960. Okay, now we are going to multiply 906 by 10 to minus 6. What it means? It means that we are going to move the decimal point 6 units to the left. Okay, let's count. Now, 1, 2, 3. 3. I need to move 3 more. Okay. So 3, I was here. 3, 4, 5, 6. So the point is going to be written here. So the result is 0.00096. Now I'm going to sum 1 plus 0.00096. What it means? It means that this number 1 is going to be written here. Let's do it. Can you see? So 1.00096 is the result. Now we are going to multiply 800 by 1.00096. That it means that the final volume is about 800.77 milliliters. All right. Well, thank you very much for watching our videos. Okay. It is really very important for the increasement of our channel, okay? Subscribe our channel as well. And share this video with all those people you love, your friends, your classmates, your parents, your siblings, okay? And of course, send us your like. It is really very important for us, okay? Thank you very much, my friends. I am your teacher, Regy Safadão, wishing you an excellent week. See you. Bye-bye.
That's all, folks.